In this video, we will use the various identities to solve problems. We will start with the fundamental identities, which are cos squared theta plus sin squared theta is equal to 1, secant squared theta minus tan squared theta is equal to 1, cosecant squared theta minus cot squared theta is equal to 1. Then the sum and difference identities, which is they are the sum alpha plus beta, or they are the differences, which is alpha minus beta. They are also called compound angles formulas because alpha and beta are angles. So compound angle is when you add two angles, it becomes compound angle. So the identities that we will look here are cos alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. Cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. Sin alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta. Sin alpha minus beta is equal to sin alpha cos beta minus cos alpha sin beta. And tan alpha plus beta is equal to tan alpha plus tan beta divided by 1 minus tan alpha tan beta, and tan alpha minus beta is equal to tan alpha minus tan beta divided by 1 plus tan alpha tan beta. Example 3.15. Find the values of cos 15 degrees and tan 165 degrees. So let's first solve the first one, which is cos 15 degrees. So cos 15 degrees can be written as cos 45 degrees minus 30 degrees. So this is in the form cos alpha minus beta. So it can be written as cos alpha cos beta plus sin alpha sin beta. Here our alpha is equal to 45 degrees and beta is equal to 30 degrees. Therefore, cos 45 degrees minus 30 degree will be equal to cos 45 degrees cos 30 degrees plus sin 45 degrees sin 30 degrees. Now substituting the values of each of them, our cos 45 is 1 by root 2 multiplied by cos 30 degrees is nothing but root 3 by 2 plus sin 45 is 1 by root 2 and sin 30 is 1 by 2. So further simplifying this, you get root 3 by 2 root 2 plus 1 by 2 root 2. So since the denominator is common, so we can write this as root 3 plus 1 divided by 2 root 2. Now let's solve the second problem, which is tan 165 degrees. So 165 can be rewritten as tan 120 degrees plus 45 degrees. Now this is in the form tan alpha plus beta. So we can rewrite this as tan 120 degrees plus tan 45 degrees divided by 1 minus tan 120 degrees into tan 45 degrees. Now our tan 120 degrees is nothing but tan 90 plus 30 degrees. So this is in the second quadrant. So our tan will be negative. So it's equal to minus cot 30 degrees. And cot 30 degrees is root 3. So this is minus of root 3. And our tan 45 degrees is equal to 1. Therefore, applying it into 1, you get tan 165 degrees is equal to minus root 3 plus 1 divided by 1 minus root 3 into 1. So this becomes 1 minus root 3 divided by 1 plus root 3. Example 3.16. If sin x is equal to 4 by 5 in the first quadrant and cos y is equal to minus 12 by 13 in the second quadrant, then find first sin x minus y and cos x minus y. So we need to find all the values of sin x, cos x, sin y and cos y. So since we are given sin x is equal to 4 by 5, we can say cos squared x plus sin squared x is equal to 1. Therefore, which implies that our cos squared x is equal to 1 minus sin squared x. So, or we can say cos x is equal to root of plus or minus root of 1 minus our sin x is 4 by 5. So 4 squared is 16 by 25. So this is nothing but plus or minus root of 25 minus 16 divided by 25, and that's equal to square root of plus or minus 9 by 25. So that's equal to plus or minus 3 by 5. Therefore, cos x is equal to 3 by 5 as it is in the first quadrant. Next, given to us that cos y is equal to minus 12 by 13 and it's in the second quadrant. So we can again say that cos squared y plus sin squared y is equal to 1. Therefore, our sin y will be equal to plus or minus square root of 1 minus cos squared y, and our cos y is minus 12 by 13. So plus or minus square root of 1 minus 144 divided by 169. So solving this, you will get the answer as plus or minus 5 by 13. Since this is in the second quadrant, your sign will be positive. Therefore, our sin y is equal to 5 by 13 in the second quadrant. Okay, so we need to first find sin x minus y, and the formula for sin x minus y is sin x cos y minus cos x sin y. Now let's replace all the values of sin x and cos y and cos x and sin y. So sin x is 4 by 5 into cos y is minus 12 by 13 minus cos x is, we have it as 3 by 5 into sin y is 5 by 13. Simplifying this, you will get your answer as minus 63 divided by 65. Now the second part of the question is cos x minus y. So the formula for cos x minus y is cos x cos y plus sin x sin y, and that's equal to, substituting the values, cos x is 3 by 5 and cos y is minus 12 by 13 and plus sine x is 4 by 5 into sine y is 5 by 13. So your answer, when you simplify this, you will get it as minus 16 over 65. Example 3.17. Prove that cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x is equal to minus of square root of sine x. So let's take the left hand side first. So the left hand side is equal to cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x. Now this is in the form of alpha plus beta and this is alpha minus beta. So let's apply cos alpha plus beta formula here. And so expanding it, this will be cos 3 pi by 4 into cos x minus sine 3 pi by 4 into sine x minus cos 3 pi by 4 cos x minus sine 3 pi by 4 sine x. These two terms are the same, so we can cancel them as they are plus and minus. So you're left with minus 2 times this term. So that's equal to minus 2 times sine 3 pi by 4 into sine x. So we can expand 3 pi by 4 as pi minus 1 by pi by 4. So this will be minus 2 times sine pi minus pi by 4. This is 3/4 of the pi. So pi minus quarter of the pi will be 3/4 of the pi into sine x. So further, we know that sine 180 minus 45 is sine 45. So this will be minus 2 times sine 45 is 1 by root 2 into sine x. So further simplifying this, you get minus root 2 into sine x, which is equal to the right hand side. Example 3.18. Point A, which is defined by 9, 12 as its coordinate, rotates around the origin O in a plane through 60 degrees in the anti-clockwise direction to a new position B. Find the coordinates of the point B. So what's given here is, you're given this point A and it's defined as 9, 12. And you need to find the coordinate of this point B, where the angle from A to B, which is in the anti-clockwise direction, is given as 60 degrees. Now the radius, let us consider, of this circle to be R. And so this length here would be 9, which is the coordinate here value, and this length here would be 12, which is the y coordinate value here. So this angle, let's consider this to be theta. Now we have to find the coordinate of B, which is nothing but the angle, which is theta plus 60 degrees. So this coordinate, we can define it as r cos theta, or sine theta. Okay, so let's start defining things here. Let A, which is the point 9, 12, be equal to A or cos theta, or sine theta, and R is equal to OA. and our r cos theta is equal to 9 and r sin theta is equal to 12. Therefore, we can find r. If we take this right angle triangle, then r will be equal to square root of 9 squared plus 12 squared. This is equal to 15. So r is equal to 15. Now the point B is, let's first define point A. So point A, the point A is now given by 15, r is equal to 15 cos theta, comma 15 sin theta. Then the point B will be given by r into cos theta plus 60 degrees, comma r sin, this is a C here, cos theta plus 60 degrees. So that will be the coordinate of this point. So the point B is given by B, or r is 15. So 15 cos theta plus 60 degrees, comma 15 sin theta plus 60 degrees. So let's find each of the coordinate. Let's first take the 15 cos theta plus 60 degrees. So 15 cos theta plus 60 degrees, it can be written as cos alpha plus beta. So 15 into cos theta into cos 60 degrees minus sin theta into sin 60 degrees. So substituting the values of 60 degrees and moving the 15 inside, we will get 15 cos theta into cos 60 degrees will be 1 by 2 minus 15 sin theta into sin 60 degrees will be root 3 by 2. Now 15 cos theta is equal to 9 because it's r cos theta is equal to 9. So replacing that value, and 15 sin theta will be 12. So 9 times 1 by 2 minus 12 times root 3 by 2. Simplifying this, you will get the answer as 3 by 2 into 3 minus 4 root 3. Now let's take the second part of the coordinate, which is 15 sin theta plus 60 degrees. So should be another bracket here. So 15 sin theta plus 60 degrees will be equal to 15 sin theta cos 60 degrees plus 15 into cos theta into sin 60 degrees. So 15 sin theta is nothing but 12. So that is 12 into cos 60 degrees will be 1 by 2 plus 15 cos theta is 9. So 9 into sin 60 degrees root 3 by 2. Simplifying this, you will get 3 by 2 into 4 plus 3 root 3. Therefore, our coordinate B is given by cos 15 cos theta plus 60 degrees will be 3 by 2, 3 minus 4 root 3, comma 3 by 2, 4 plus 3 root 3. Example 3.19. A ripple tank demonstrates the effect of two water waves being added together. The two waves are described by h is equal to 8 cos t and h is equal to 6 sin t, where t belongs to the interval 0 to 2 pi, is in seconds, and h is the height in millimeters above still water. Find the maximum height of the resultant wave and the value of t at which it occurs. So you must be familiar with the ripple tank experiment, which is done in the physics lab. So you are using this experiment to see the property of the wave which it forms. Now, what we're given here is the height of the wave is the combination or the sum of these two functions, which is 8 cos t and 6 sin t. So if let us define h, let be the h be the height of the resultant wave at time t. Then our h is equal to the sum of these two, which is 8 cos t plus 6 sin t. Now, if we can express this in terms of k cos t minus alpha, then we know that cos t minus alpha will take the maximum value of 1 when t is equal to alpha, which will be cos 0 degrees, which is 1. Then finding the value of k would be the solution. So let's try and break this down and express in this form. So I can rewrite this as, if I take 10 as a common number for both outside, then this will become 4 by 5 cos t plus 3 by 5 sin t. Now, if you look at 4 by 5 and 3 by 5, they are the sides of a right angle triangle. So if the hypotenuse is 5, then this is 3 and 4, and we define the angle as alpha. Then we can say that our sin alpha is equal to 3 by 5, which is here. Now cos alpha is 4 by 5. So this is equal to 10 times cos alpha into cos t plus sin alpha sin t. Now this is in the form of cos t minus alpha. So this can be 10 into cos t minus alpha. So h is equal to 10 times cos t minus alpha is our new function, or the function for the height of the wave. So from this we can say k is equal to, or k here is equal to 10, and our tan alpha will be equal to 3 by 4. From the right angle triangle we can clearly say that. Therefore, since this is our new function, or the function which describes the height of the wave, the highest point that it can have is when cos t minus alpha takes the highest value. Cos t minus alpha will take the highest value of 1. The cosine curve will take the maximum value of 1 when cos is 0 degrees. Therefore, the maximum of h is equal to 10 into 1, which is 10, and the measurement is in millimeters, so it's mm, and the maximum occurs when our t is equal to alpha, because when t is equal to alpha, this becomes 0 degrees, and where our tan alpha is equal to 3 by 4. Example 3.20. Expand. First one is sin A plus B plus C and second is tan A plus B plus C. So let's take the first one, which is sin A plus B plus C. Now we can further segregate this as sin A plus B plus C. So this is like sin alpha plus beta. So applying the formula for sin alpha plus beta, we get sin A into cos B plus C plus cos A into sin B plus C. Now further, cos alpha plus beta, let's apply that formula into this and sin alpha plus beta onto this. So this becomes sin A cos B cos C plus cos A sin B cos C plus cos A cos B sin C minus sin A sin B sin C. Now let's expand tan A plus B plus C. Tan A plus B plus C. That's equal to tan of A plus B plus C. So further applying the formula of tan alpha plus beta, we get this to be tan A plus tan of B plus C divided by 1 minus tan A into tan B plus C. Now further, let's apply tan alpha plus beta onto each of them. This B plus C here and this B plus C here. So this will be equal to tan A plus tan B plus tan C divided by 1 minus tan B into tan C divided by 1 minus tan A into tan B plus tan C divided by 1 minus tan B into tan C. Further, simplifying, we will get the answer to be, because 1 minus tan B tan C can be, we make them as the common denominator for the numerator, and for the denominator we can cancel them out. So this would be tan A plus tan B plus tan C minus tan A tan B tan C, the whole thing divided by 1 minus tan A tan B minus tan B tan C minus tan C tan A. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.